Missions to Jupiter's icy moons and China's youngest ever crew blasting off to the space station. Just a few of the out-of-this-world developments this year. They've certainly made an impression on Professor James Head, who trained astronaut crews and participated in the Apollo moon program. I spoke to him to discuss this year in space.
Well, you know, every year I tell my new students, this is the best possible time you could be going into planetary science. And I'm thinking, wait, I say that every year, but it's absolutely true. And 2023 was absolutely fabulous. We launched JUICE, the European Space Agency, to the Jupiter system. We have the Juno already there. We have Lunar Reconnaissance Orbiter going on. We have 2 Mars rovers, 1 Mars orbiter. Great results from the Chinese rover on Mars, etc. India broke the curse, if you will, and was successful in landing Chandrayaan-3 on the moon. This is spectacular. One of the best things is that China opened up its access to their Chang'e 5 lunar return samples to the international community, and NASA approved U.S.-funded investigators to actually apply for those samples. So that's great news. But that's not all. I mean, my gosh, the orbital things that were going on in Earth orbit. We celebrated the 23rd anniversary of human presence in space with the International Space Station. And Chenzhou, I mean, there were like fabulous missions. The Chinese space station was completed. The youngest crew ever was set up. Really great to see those 30-year-olds. I mean, why not? You know, that's the future. So it was a fabulous time. I mean, the only thing is that 2024 seems to be even better.
Well, let's talk about that. Let's talk about 2024, because for China in particular, it's set to be a big year for space.
You know, I'm really looking forward to the Chang'e 6 mission, which will be the first lunar sample return from the far side of the moon. I've worked closely with my colleagues in China, talking about the greatest landing sites, and actually co-authored a paper with them on the Chang'e 6 landing site. So we're totally excited about that. The international community is just totally excited. We don't have samples from the far side of the moon. That's half the moon, okay? And one of the things is, you know, when you go to the moon or space, you end up with essentially you basically carry your house with you. It's really, you need the protection, okay? So the spacecraft is the house. And that's like a turtle. You know, turtles carry their house with them, okay? And then they just curl up inside. But you can't do that if you're going to stay on the moon. So we've been actually trying to understand how you can reduce the mass you have to take to the moon. You don't want to take a lot of bricks and cinder blocks to the moon. So we've actually been doing research on bio-bricks. This is a bio-brick. And basically, if you look at it, it's wow, fairly light. It would be grown in situ, like on the moon. It's made up of mushrooms. It's mycelium. So you take the spores, et cetera, the seeds, if you will, to the moon. You mix them with water and other regolith and things like this, and you build these biobricks. So we're doing this research for the future of NASA to try to understand how we can reduce the upmass and build houses on the moon. And this is really important, because the last thing is that when you do this, we're actually looking at how you apply this to building houses on the Earth, so that we can reduce the catastrophe coming from international migration and things like that, where people don't have a place to live. So all of these applications really come back to the Earth and help as well.